Thank you very much for your support and your colleagues to work this together with me and to make the students' learning enrichment much more fruitful.
I would like to thank you too for the excellent cooperation, and I wish for a new collaboration in the future.
Yes, definitely. We'll work more. I'll work more with Theodos. Introduce the school a bit. We are kind of the only international boarding school in the Netherlands. There is another boarding school, but it's not international. It's owned by the Dutch school. So we are kind of the only one in the Netherlands. So we are a very small school. We have our primary program all the way up to the high school program, running all international program. At the primary level, we do the International Primary Curriculum, IPC. And in the middle school, we do IMYC, International Middle Years Curriculum. And then we have the IGCSE, which is the Cambridge high school program. And finally, the pre-university, we have the IB, International Baccalaureate Program. So I'm teaching the International Baccalaureate Program and also the IGCSE program. Yeah, and we are only having about 70 students only from primary to high school. So my class size is very, very small. For example, today, I only have 3 students going to present in this Eratosthenes experiment. Yes. Yeah.
Κυρία.
Έλα, αγάπη μου.
Αυτοί δεν έχουν κορονοϊό εκεί.
Έχουνε.
Hello.
Hello again. Good morning.
A short greeting for our principal, Georgia Katsadima, to you and your students.
Hello, guys.
Hello.
Congratulations.
All right.
Bravo, Darius, Daniel, and Oleg.
Yes.
I would like to tell you that today we live in the age of technology, and Eratosthenes teaches us that the most powerful weapon for the acquisition of knowledge are the passion for new discoveries and experiences, and the questioning of what we think that we know, and of course to have a clear and critical thinking. He didn't have technology. Okay, so if you want to make yours new knowledge, you must want it very much and work.
All right.
First, we'll introduce ourselves. So, Daniel, you may start.
Okay, I'm Daniel. I'm from the International School of Eerde. I'm a Spanish student doing IB1, and we're going to present the aerostatic experiment.
I'm Darius. I'm also at International School of Eerde, same year. We've been working on this presentation together as a team now.
Yes, same. My name is Oleg, and I'm from Ukraine. I'm also in the same grade and the same, basically, year. So now I think we'll start.
Okay, so for the Eratosthenes project, made by me, Darius, and Oleg. For the first method we used was a phone app. This method is based on an app on our smartphone devices. This app knows exactly where the sun is at all times and gives measurements depending on our geographical location. With this app, we can get the angle, the time, the position of the sun, and the sunrise and sunset of the sun, depending on where you are. This app is called the Sun Surveyor. As you can observe, you have to point with the digital cross on the app where the digital sun is, so that it gives you the information of the position. We did this at the exact time of the solar noon time, so that other schools can do it at their own solar noon times. You can see at the right, there's an image of how the app worked and where you have to point the cross and everything. This is the data that we obtained. We obtained the angle of declination by minusing the angle of elevation to 90. We use this because we are working with a right angle triangle. And now I'm going to pass it to,
we wanted to make a remark that we use this app only because the day was very gloomy, and so we couldn't get we couldn't do a proper experiment.
So the next method that we could have used, and also to check our data was correct, was a website called suncalc.org. basically you can put in your GPS coordinates or just find yourself on the map and you put the circle or crosshairs where you are. And on the left side of the screen, it'll show you dawn, sunrise, sunset, dusk, everything that you'll need to know. You can even change the object length and also shadow length that it'll cast. So everything's already calculated for you depending on the length of the object you'll be using. So suncalc.org, what we would have done if we use this method would be to find the x, we'd just find hypotenuse and all the other measurements from the stick. Suncalc would find the shadow length, and then we could just work out the x value of the angle.
Yes, so basically what I did, I saw that we need to go a bit further than just calculating the raw value, so I decided to propagate the value. So scroll back. So at the left top corner, you can see the hour angle with the error, with the uncertainty of it. So what I did, so I calculated the average uncertainty. Then I used the angles of all the schools we were provided with, and I also took the error, but we have two errors from it. So if we use trigonometrical value, we'll get this kind of value, and if we assume that the school uses a protractor, we'll get that kind of value, plus minus 0.5. Then the differences in value, you can also see how the error propagated further away. Then for the distance, I took an error to be plus minus 20 meters for each one, depending on the site. Some websites said that it is 7 meters, some said it is 12, so I decided to take an average. So then I used the method of unfractional value. I found the unfractional values of differences in angle and the distance. Then I added them together and multiplied by the final result to get the uncertainty in the final result, in the final calculation. And that's what we got. So then when we go to the percentage error, how do you scroll it? Yeah. So then when we go to percentage error, we can see that the smallest percentage error in our calculations is the one that has the highest distance and the highest difference in angle. And this can be simply explained because when we have the bigger distance, the uncertainty in the distance is way smaller. That's why the uncertainty will be lower. So basically from this document and from this data analysis, we can conclude that for the next experiment, the best way to get precise, more accurate results is to take the data from the schools that are further away from you. In that way, you'll get the smallest uncertainty and your value will be the most accurate one.
Your very detailed and accurate presentation. Well done,
Thank you.
Darius.
Thank you.
Well done,
Bravo.
Ole and Daniel. Yes.
Bravo.
Yes,
So,
thank you.
Congratulations, kids.
Congratulations.
Thank you.
Very good work.
For our
Thank you for the
presentation.
kind words.
Okay. So now we proceed to our presentation. Prepared two videos and one photo. This is Mr. Chi Wong, your chief team in the Netherlands.
Thank you, very nice.
All right. And now, I'm happy you like it. And now we proceed to the first video that Vaggelis made it with the collaboration of the other team of ours. Let's see it.
Hi, I'm Iωάννα Καραμάνη.
And I'm Thános Καραμάνης. We are students of 21st Γυμνάσιο Athens, and as you can see, it's a very sunny day.
To do the experiment, we use a rod 1 meter. To measure the shadow, we use the measure type. And to see if the angle is right, we use a triangle.
Oh, hi Panteleis and Konstantinos. What did you use to do the experiment?
Hello Iana, hello Thanos. The weather is really nice here.
So we can finally proceed with our Eratosthenes experiment. We are going to measure this object. It is a Greek bankhamon, and we are going to measure it with this ruler. Oh, Andrew, what about you?
Hello, Kωνσταντίνος and Panteleis. I am Anδρέας Κορωναίος. The weather is really helpful here for doing Eratosthenic experiment. In my turn, I will use this iron rod and measure its shadow with this measure tape. Hey Vaggelis, what about you?
Oh, hello Andrew. I am Vaggelis and I am a student of 21st Junior High School, Athens. To do the experiment of Eratosthenes, I used this 32 meters ruler and another ruler to measure the angle of elevation from the horizon. Additionally, as you can see, it is a wonderful day and we have the possibility to do the experiment normally. Oh, hello Dad student, what about you?
Oh, hello, Vaggelis. Today we don't have good weather. I mean, we have some clouds. But we found the way to measure the angle of elevation from the horizon with an application called Sun Surveyor, which tracked the position of the sun.
Γεια σας, είμαι ο Παντελής Καράμπελας, είμαι μαθητής της 3ης Γυμνασίου στο 21ο Γυμνάσιο Αθηνών. Αυτός είναι ο αδερφός μου ο Κωνσταντίνος, είναι στην 1η Γυμνασίου στο αντίστοιχο σχολείο. Έχουμε μετρήσει ένα τάβλι, το οποίο έχει μήκος 47,2 εκατοστά και η σκιά του, όπου μετρήσαμε με αυτόν εδώ το χάρεκα, είναι 35,1 εκατοστά. Ευχαριστούμε. Hello, I am Panteleis.
Hello, I'm Constantine.
We have finally taken the measurement of our object. The shadow is 35.1 centimeters long and the object is 47.2 centimeters.
Thank you.
For my own experiment, I used a measure tape and an iron rod. Good morning, my name is Anδρέας Κορωναίος and I am a student of the 21st High School of Athens. As we all know, more than 2,200 years before Christ, most people thought Earth was flat. They believed that the edge of the world was put as far as their eyes could see. But there was an astronomer, mathematician, Eratosthenes, who believed that Earth was round, and he managed to calculate its perimeter through an experiment. All he used were 3 tools, one vertical stick, a measure, and the sunlight. For my own experiment, I used a measure tape and an iron rod.
After 5 consecutive years that our school, 21st Gymnasium of Athens, makes the Eratosthenes experiment, this year, 2021, we collaborating for first time with another school of Holland, the Eerde International Boarding School, after the kind invitation of Mr. G. Wong. On Monday, 22nd of March, at 12:33 here in Athens, the sun made us a favor and saw itself away from the clouds, never disappointed us all these years, at least at the time of the experiment. Unfortunately, and this year, second in a row, we did the experiment from the roofs of our homes because of the COVID-19 lockdown. I'll show you our team for this year and their work through an Excel and photos. I'll also tour you to our country and its history that has to do with Eratosthenes. Let me introduce you. Thanos and Ioanna, Andreas, Vaggelis, Pandelis and Konstantinos, and the physics teacher Mr. Paradises. They all did the experiment from their terraces. Here you see the coordinates of the Dutch school. The longitude, that is the angle of north and south from the equator of course both of schools are from Europe, and that means from North Hemisphere. Further north is the Eerde. That's why the angle 1 was bigger than ours, angle 2. We chose the angle 1 as the average of 5 trials they did. You can see here. To find the right distance for our calculation, we projected the spot that Mr. Wong's team made the experiment to the line of our longitude. That is the angle of west or east from the Greenwich meridian. Both schools are east from the UK, but Holland is closer than Greece. That's why the Eerde longitude is smaller than ours. You could understand better the distance we used for our calculation from these pictures. So, the projection from Eerde to our longitude goes to that blue pin. There. This pin is in Belarus. Too close to the borders with Poland. As we go down to find Athens, it passes by the countries Ukraine, Poland, Romania, Bulgaria, close to its capital Sofia, and we welcome you to Greece. I'm going to mention just the areas of our country as the line of our longitude passes by to its way to Athens. First, it's the glorious and known from Alexander the Great, Macedonia, and its capital, the beautiful Thessaloniki. You'll see later on the relation of Alexander the Great with Eratosthenes experiment. Further south, it's Halkidiki and Mount Athos. Close to that spot, further west, it's the Mount of God's Olympus. Then it's an island complex called Sporades. After that, it's Evia. If we follow the line down from Athens, we meet Crete. Here's a nice photo of the old Venetian harbor of Chania that I can't wait to visit again. A little south from that is the south border of Greece and Europe too, a little island called Rhavdos. I extend the longitude line beyond the Mediterranean Sea to reach Africa. And further east that line, or further south to the sea area between Crete and Cyprus, to meet the city that Alexander the Great founded at 321 BC, 8 years before his death at the age only of 32, and gave it his name, Alexandria. There, at the port, stood for 1,500 years the exceptional and considered one of the 7 wonders of the ancient world, the lighthouse of Alexandria, called Pharos, the Greek word of lighthouse, and metaphorically sends the light of thought and knowledge to all over the known world, then, now, and in the future. An example of that is the Eratosthenes experiment. Eratosthenes was a headmaster of the best library in the world in Alexandria and made the famous experiment at 240 BC. To honor him, schools from all over the globe repeat his experiment every year, especially on spring and autumnal equinox. So let's go to Athens, our home city, and have a look to the data of our teams.
2,000 years later.
First, at the line, this one, are the distances every team used. There are the length of sticks and the shadows they wrote down. And through this, they calculated the angles that appears at this line. As a result of subtraction of the Eerde angle 1, we found the calculation angle that you can see here. Finally, every team calculated the equator and radius. You can see also the percentage of the typical error from the real length of the equator and radius that you can see here. From the data above, the conclusion is that accuracy and precision are very important for this experiment. For example, less than 1 unit difference at the angle makes more than 6 units of an error percentage deviation. So that is all. Hope you like it.
Thank you. It was really great. Yeah, all the creativity and your work for the first video. I'm not sure if you guys want to comment about something, what you have watched.
Very nice. Very beautiful approach.
So I thank you for all your efforts, because this is a lot of efforts to make the video from the students and from you. It was a lot of work. It was impressive. It is a very good opportunity to know about the historical background about Eratosthenes.
Thank you very much.
You made an excellent work. Bravo.
You guys too. You did a very good job. Thanks to all of you. Okay. Have a good day.
Thank you.
Okay.
See you.
Have a good day.
Bye.
Bye bye.
Bye.
Bye bye.
Λοιπόν,
Μπράβο, αγάπες μου. Καλά, Ζωγραφίσατε.
έχω 18 άτομα και περιμένουν. Είναι το Α2.
Δεν πειράζει. Περήφανη. Τι ωραία δουλειά ήταν αυτή. Μπράβο.
Ευχαριστούμε.
Να μιλήσουμε και στην ωραία γλώσσα μας.
Τους βάλαμε και πολλές ελληνικές λέξεις.
Μπράβο, αγάπες μου. Μπράβο, συγχαρητήρια. Πάντα τέτοια. Και να θυμάστε, το μυαλό είναι το μεγαλύτερο όπλο. Το μυαλό, χωρίς τίποτα. Με μια βεργούλα ο Ερατοσθένης. Έτσι. Ο άνθρωπος όταν θέλει μπορεί τα πάντα. Καλή συνέχεια και ευχαριστώ πάρα πολύ για αυτή την υπέροχη ώρα που πέρασα μαζί σας. Περήφανη.
Γεια σας, κυρία.
Γεια σας, κυρία.
Bye bye.
Γεια.
Γεια.